Okay, today's lab we're going to be using conductivity to find the equivalence point. Now this is an interesting lab and it's purposely set up to do what we want. So we're going to be titrating barium hydroxide with sulfuric acid. It is just a standard neutralization reaction with an acid and a base. So we're making an ionic salt and water. Barium sulfate's the ionic salt. This one's going to be pretty neat though, because the barium sulfate actually precipitates out and it creates a very interesting way for us to test for the endpoint. Now, endpoint really is when that first half the reactants are fully balanced. Both of the reactants have run out. Now, at that point, if this was perfectly eliminated, both these spectators are now gone, and the only thing in that solution was barium sulfate and liquid water. Well, that's perfectly great if they're there. This would be an interesting procedure. As we titrate, we'd see a white powder build up in there, and it would start forming almost right away. And our endpoint would be when that white powder stops forming. Well, if you think about that, that's going to be pretty impossible to actually observe, because you're looking for a point where suddenly it looks less cloudy. So we don't even bother to try that. What we're going to do instead is we're going to realize that neither one of these, pure distilled water and the barium sulfate, would have any electrolyte properties whatsoever. It will not conduct electricity. Yet both the titrant and the titration material would. So these guys both conduct electricity. So what we're going to do is we're going to use a conductivity probe, and we're going to slowly add our components. And as we get closer and closer to this endpoint, our conductivity is going to drop and drop and drop. And as soon as we've passed the endpoint and started adding more of the sulfuric acid into it, we're going to start to see the concentration of the conductivity go up again. So what we're going to be doing is looking for a point where it goes to its lowest possible. It'd be great if it goes to 0, but our probes really aren't that good. We're going to see how close to 0 it gets, and then try to get the equivalence point, or we're going to get our endpoint based on the conductivity directly. All right, let's get into the lab.